Yeah, you all know about OneWeb because they were just on the last panel, or the opening panel, I believe it was, or the one just before here, actually. And SpaceX has an initiative, and then a whole bunch of people are coming out of the woodwork wanting to put up these large constellations of satellites to provide broadband to everyone. I think this is a really huge business opportunity. It will be probably one of the biggest economic boons from the space industry over the next 10 years. In other words, the thing that will make the most economic impact on the most people, bringing 4 billion people online for the first time and becoming part of the global economy is perhaps unprecedented in human history. And so we are applauding as loudly as we can every initiative in this regard to have more net neutral pipes to the home business and everywhere in between. Just last week, I took some photos of the latest OneWeb ground terminal and model of their satellite, which is very different than it used to be when they were over at Google. And that's one of the contenders, as you heard, that just raised a bunch of money from SoftBank. And we can talk in Q&A why that's technologically different from Teledesic and other predecessors that had some trouble. The last example beforehand is jumping out of the business side. I've also been a supporter of B612 over the years, and this is a nonprofit. I encourage all of you to check them out. Started by Rusty Schweikart of Apollo 9. And Ed Lu, who's flown many times to Shuttle and Soyuz. And the idea there is that you can put a satellite in a Venus-like orbit looking out, and for an all-in cost of about $400 million, this is the old product, but that's what caught my attention. For $400 million all-in cost for launch, operations, satellite, and everything, you could detect all possible threats to extinguish life on Earth, or even city-size, sort of planet-busting or city-busting kinds of asteroids, with a forward-looking 50 to 100-year trajectory, modeling the n-body problem. It's basically become a computational possibility that if you have 3 points in a line, you can now predict the orbital dynamics that far out, so that you could do this incredible thing, and we should do that for less than the cost of a new wing on the Asian Art Museum in San Francisco. You could protect all the artifacts, was sort of my thought back then. The update in the last few months, though, that's fascinating, is I've been relentlessly fixated on the sensor cost. It's a cryo-cooled IR sensor. Really seems strange that it needed to be so expensive. So even though it was $400 million, big chunk of the cost, almost half the cost of the satellite was the sensor. And sure enough, after a bit more software development, a bit more putting more computational load into the satellite, sure enough, a cluster of small sats, as few as 8, could do almost as good a job at 1/100th the cost. And this is some partially published work, and they'll be doing more work in this area and doing some actual flight tests as well. But it just is a great example of the small sat revolution. Off-the-shelf components, moving into the satellite, computational elements, or storage of data sets that you otherwise couldn't. In this case, it's synthetic tracking that they put in satellite. And being able to do things that just weren't possible before. Because in many industries, you don't find 100Xs. Entrepreneurs dream of a 10X. They often don't achieve that. They rarely even claim they're going to make a 100X. And you'll see this everywhere in the small sat industry, that the march from the mainframe class machines down to the little mobile or laptop-sized computers, if you will, in space, is really what it's all about. Some people had the foresight to know this many years ago. Today, it's blindingly obvious that the future belongs to the small, the nimble, the agile, and the commercial off the shelf. So with that, let me end and